Hi guys, welcome back to Zero Academy. In today's grade 11 mathematics lesson, we are going to be looking at finance, growth and decay. We'll begin with a quick revision of simple and compound interest, then we'll move on to simple and compound depreciation. After that, we'll look at timelines, especially when the interest rates change during an investment period. And finally, we'll look at nominal and effective interest rates. Let's get started. Simple interest. Simple interest, as introduced to you before, is the interest calculated only on the principal or initial amount invested, and its formula is A is equals to P 1 plus I N. Next, we have compound interest. Compound interest is the interest calculated on both the principal amount and its accumulated interest, and that is defined as A is equals to P 1 plus I all to the power N, where A is the accumulated amount or the future amount, P is the principal or the initial amount, I is the interest rate written as a decimal, and finally, N is the time period. Now let's take a look at a quick example. Jane wants to invest 5,000 rands. Smart Bank offers 12% per annum simple interest rate, and Zero Bank offers 11% per annum compound interest rate. Which bank will give Jane the highest accumulated amount at the end of 7 years period? Let's see how we solve this one. Let's see how we solve that one. First one, let's solve for the 12% per annum simple interest rate. We're gonna go on and say we are given P as 5,000, I is 12 divided by 100, which is equals to 0.12, and number of years is 7. And introducing our formula, A is equals to P 1 plus I N, and substituting in our values, we'll have A is equals to 5,000, 1 plus 0.12 multiplied by 7, and that will give us an A value of 9,200. After 7 years on the simple interest rate, she will have 9,200. Now let's check the 11% per annum compound interest rate. Again, P is 5,000, but interest rate this time around is 11 over 100, 11%, which is equals to 0.11, and number of years remains the same, is 7. And introducing our formula, we'll have A is equals to P 1 plus I all to the power N, and substituting in our values, we'll have A is equals to 5,000, 1 plus 0.11 all to the power 7, and that will give us a future amount of 10,280 rands 80 cents. And that doesn't surprise us that the compound interest one is a higher future amount, even though the interest is low, because the interest rate on compound interest is calculated on both initial amount and the interest rates it accumulates throughout the 7 years periods. To conclude that question, Zero Bank will offer Jane highest amount. And now moving on to simple and compound depreciation. As you know, as soon as a new car leaves the dealership, its value starts to decrease and is now considered as second-hand, or whatever term you use. And this applies to all assets such as machinery, equipment, etc. They all lose value because of usage and time. This loss is called depreciation. There are two types of depreciation, which is simple decay and compound decay. Simple decay, otherwise known as straight line depreciation, is represented by the formula A is equals to P 1 minus I N, otherwise the simple interest formula, but we change the positive sign to be the negative sign in between the 1 plus and I N there, as you can see. And next we have compound decay, otherwise known as reducing balance depreciation, and its formula is given by A is equals to P 1 minus I to the power N. Again, is the compound interest, but we just change the sign in between. Now let's take a look at an example. Before we actually move into this exercise, please just quickly check out our website. It will be worth your while. Hi guys, if so far you are finding this lesson tolerable, please head on to our website using the link in the description below, and from there you can select the menu, select your grade, and select your subject, select the paper of that subject you want to study, and from there you will find the study materials of that particular subject paper, from YouTube videos to presentations to quizzes. Presentations are the notes I use on these videos, including the notes of this video. You can find them on the website using the link in the description. You don't need to take screenshots. Everything is there on the website for free. You can download the PDF papers, and when you're done going through the materials, you can always take a quiz to test your knowledge. And the quiz is 15 minutes time limited. You can go through the quiz, taking it from one question on to the next, as you can see me doing. And when you're done taking the quiz, it will show you your score along with the percentage, along also with the memo of the questions you took, as you can see on my screen. And if you feel like you want to take the quiz again, you can always try again. If you feel you're confident that you've mastered the quiz, you can go back to the paper and continue with your studies. So please head to our website using the link in the description for all the study materials you might need. Thank you. A truck is valued at 700,000 rands. If it depreciates at 13% per annum using straight line reducing balance, calculate the value of the truck after 6 years. We write down the given information. Principal amount or the initial amount is 70,000. Interest rate is 13%, which is 13 over 100, which is equal to 0.13. And number of years is 6. And introducing our formula, we'll have A is equal to P, 1 minus I, N. And substituting in our values, we'll have A is equal to 70,000, 1 minus 0.13 multiplied by 6. And that will give us a future amount of 154,000 rands. And that answers that particular question. Let's move on to the next question. Zero Academy buys a new laptop for 25,000 rands. After a period of 10 years, the value of the laptop depreciates to 0 rands. What is the value of the laptop after 7 years? This time around, we are not given an interest rate, but we are given the value of the laptop after 10 years. After 10 years, the laptop is completely used up. It has no value, it's 0. And hence, we can go on and say, the value of the laptop depreciates by each year, and the rate at which it decreases by, we can calculate it by saying depreciation is equal to 25,000, which is the initial amount, divided by 10, the number of years it takes for the laptop to be worthless. And that will give us a value of 2,500 rands. That means each year that passes, that laptop loses a 2,500 rands value. And hence, to calculate for the value of the laptop after 5 years, we're going to go on and say A is equal to 25,000, which is the initial amount, minus 7, which is the number of years in which we're interested in, multiplied by 2,500 rands. And hence, this laptop has lost 2,500 rands. And after this time, it will be worth 7,500 rands. And that is how you solve that particular question. Now, let's move on to compound depreciation. Owen buys a new smartphone for 15,000 rands and depreciates it at 5% per annum using the compound depreciation method. What is the value of the smartphone after 7 years? Again, we start by writing down our given information. Principal or initial amount is 15,000. Interest rate is 5 over 100, 5%, which is equal to 0.05. And the number of years is 5. And now introducing our formula, we'll have A is equal to P, 1 minus I, all to the power N, and substituting the values that we know, A is equal to 15,000, 1 minus 0.05, all to the power 5, and that will give us a value of 11,606 rands 71 cents. That is the value of the smartphone after 5 years. Now let's move on to timelines. Timelines are a bit difficult, bit complicated, but very easy. You will see after these explanations. Sometimes interest rates are compounded more than once per year, that is monthly, quarterly, weekly, or daily, etc. Whatever they say in the question. And this is when we need timelines. Below is a table of compounding terms and their corresponding p-values. When the term is yearly, we multiply the number of years by 1. When the term is half-yearly or biannually, we multiply the number of years by 2. When it's quarterly, we multiply the number of years by 4. When it's monthly, we multiply the number of years by 12. When it's weekly, we multiply the number of years by 52. And when it's daily, we multiply the number of years by 365. And to summarize everything I've been saying, explaining this table, when amounts are compounded more than once per year, we multiply the number of years N by P, and we also divide the interest rate by P. Now let's take a look at an example. 10,000 Rand is invested for 5 years. For the first year, the interest grows at a simple interest rate of 14% per annum, and for the rest of the period, it grows at 16.5% per annum, compounded quarterly. What is the value of the investment after 5 years? Now, to represent that information in a timeline, we will have T0 up to T5. T0 up to T5. Be careful, we don't start at T1. We always start at T0, T1, T2, T3, T4, up to T5, and T0 at the beginning of the year 1, the deposit was made of 10,000 rands, and at T1, as you can see by the dotted line, the interest rate changed from 14% per annum simple interest to 16.5% per annum compounded quarterly. After 1 year, that is between T0 and T1, we want to calculate how much we'll have at this time. We introduce our simple interest formula as it is 14% per annum simple interest, and hence we'll have A is equals to P 1 plus IN, and substituting in our values, we'll have A is equals to 1,000, 1 plus 0.14 multiplied by 1, because that is after exactly 1 year, and hence we'll have an accumulated amount after 1 year of 11,400 rands. Now, we're going to move on to the compounded quarterly region. That is between T1 and T5. Here, again, we're going to introduce the compound interest formula because this is compounded quarterly. And hence we'll have A is equals to P, 1 plus I, all to the power N. And substituting in our values, we'll have A is equals to 11,400, which is the accumulated amount after 1 year, all multiplied by 1 plus 0.165 divided by 4, all to the power 4 multiplied by 4. Because it's compounded more than once per year, we divide the I by P and we multiply the N by P, which is 4 in this case. And that will give us an accumulated amount after 5 years of 21,766 rands 32 cents. Now, here, for the number of years, we calculate from T1 up until T5, not from T0, because from T0 to T1, that is simple interest. We are interested from T1 up to T5, and that is 1, 2, 3, 4 years. And hence, the number of years here is 4. And that will give us an accumulated amount of 21,766 rands 32 cents. Now, let's move on to a more complicated, more challenging question. 150,000 rands is deposited into an investment account for a period of 8 years at an interest rate of 10% per annum compounded half yearly for the first 5 years, and then 7% per annum compounded yearly for the rest of the period. A deposit of 15,000 rand is made into the account after 2 years. Then another deposit of 5,000 rand is made after 6 years after the initial amount investment. Calculate the value of the investment at the end of 8 years. Here we have a total of 3 deposits, and hence we're going to need to calculate the accumulated amount for 3 of them. Now, let's represent all this information in our timeline. We start from T0 again up until T8 because that is the total number of years. We start from T0, T1, T2 up to T8, and at T0, 150,000 rands investment is made. T1, and at T2, we add another 15,000. T3, T4, T5, and at T6, we add another 5,000 rands. And from T0 up until T5, the interest rate is compounded half yearly at 10% per annum. And from T5 up until T8, the interest rate is 7% per annum, compounded yearly. Now, let's calculate the accumulated amount for the 150,000, the initial deposit. After 5 years, that is from T0 up until T5. Number of years is 5 multiplied by 2, which is n multiplied by 2 because it's biannually or half yearly, and hence we'll have 5 multiplied by 2, which will give us 10. And the interest rate here is 0.1 all over 2, which is equals to 0.05. Next, after 8 years, that is from T5 up until T8, and that is 3 years, a total of 3 years from T5 up until T8. 8 minus 5 is 3. And here, the n value is 3. That is not multiplied by anything because it's compounded yearly. That is once per year, and hence we don't multiply the n by anything. And again, the interest rate, we're going to take it as it is, which is the 7%, and hence 0.07. And now we can go on to calculate the total growth of the initial deposit. We're going to introduce our compound interest formula, which is A is equals to P1 plus I1 to the power N1 multiplied by 1 plus I2 to the power N2. Notice that here we have 2 1 plus I to the power N's. That is because we have two different interest rates. If we had three different interest rates, those 1 plus I to the power n's would have been 3. But in this case, there are 2 and hence we'll have 2. 1 will label it I1 and N1. 2 will label it I2 and N2 as I have done. And now, substituting in my values, I will have P is the 150,000. That is our initial amount. 1 plus the first interest rate, which is from T0 up until T5, which is 5%, which is 0.05, all to the power 10, which is 5 multiplied by 2, multiplied by the second interest rate, 1 plus 0.07, all to the power 3. And that will give us an accumulated amount of 299,319 rands, 89 cents. And now we are done with the 150,000 deposits. We're going to move on to the 15,000 deposit. And the accumulated amount for the first or initial deposit, I'm going to write it at the top of my screen next to solutions, as you can see there. And for now, I'm going to focus on the 15,000 rands deposit. And this time around, after 3 years, because this deposit was made somewhere in between the half-yearly compounded interest rate, not at the beginning. It was made at T2, and hence the time it spent within this region of compound interest is T3, T4, T5, and hence 3 years. That is between T2 and T5. 5 minus 2 will give us 3 years. And again, we'll have N3 is equal to 3 multiplied by 2, which is equal to 6. That is number of years multiplied by P. 3 being the number of years and 2 being the P. And hence we'll have 3 multiplied by 2. That will give us 6. And I3 will be 0.1, all divided by 2, because again it's compounded half yearly, and hence we divide I by 2, and that will give us an I value of 0.05 as before. And now we're going to move on to the second region of the compounded yearly interest, the 7% one. That is from T5 up until T8. That is 8 minus 5, that is 3 years, and hence N4 will be 3. We don't multiply it by anything because it's compounded only once per year, and hence it will remain 3. And again, I4 will remain the 7%. We don't divide it by anything, which will be 0.07. And now we have all the necessary values. We can go on and calculate the total growth of the 15,000 rands deposit. Again, I'm going to introduce the formula as the previous one with 2 1 plus i's. That is A is equals to P, 1 plus I3 to the power N3, all multiplied by 1 plus I4 to the power N4. And substituting in my values, I will have A is equals to 15,000, 1 plus 0.05 to the power 6, all multiplied by 1 plus 0.07 to the power 3. And that will give us an accumulated amount of 24,625 rands 12 cents. And we are done with the 15,000 rands deposit. We can move on to the final deposit, which is the 5,000 rands deposit. Again, A2, I'm just going to write it at the top of my screen, as you can see there. And now I can focus on the 5,000 rands deposit. Now, the 5,000 rands deposit, it was invested at the second region or the last region. It was not invested in the first region, and hence the 10% per annum compounded half yearly, it doesn't affect the 5,000 rands deposit as it was not invested then. And hence it only needs one interest calculation, and that is between T5 and T8, or T6 and T8 rather, and that is 2 years. And hence after 2 years of its investment, N5 will be 2. That is the number of years it spent within the 7% per annum compounded yearly interest rate region. And again, the interest rate is 7%, 0.07. And now I am ready to introduce my compound interest rate to calculate the interest earned by the 5,000 rands deposit. And that will be A is equals to P, 1 plus I5 to the power N5. And substituting in my values, I will have A is equals to 5,000 rands, 1 plus 0.07, all to the power 2, which is the number of years. And that will give us an accumulated amount of 5,754 rands 50 cents. And now to get the total accumulated amount of the 3 deposits, we just simply add the A1, A2, and A3, the three accumulated amounts, and in doing that, we'll have total accumulated amount is equals to 299,331 rands 89 cents plus 24,625 rands 12 cents plus 5,724 rands 50 cents, and that will give us a total accumulated amount of 329,669 rands 21 cents, and that is the final part of that question, and hence we've answered that particular questions. So as you can see, timelines are very detailed, and if you draw them with enough details and with precise information, you should have no difficulty in dealing with it. Now we can finally move on to the last section of this video, which is the nominal and effective interest rates. We have seen that although interest is quoted as percentage per annum, it can be compounded multiple times per year, as we saw when we were dealing with timelines. Therefore, we need to find some way of comparing interest rates. For example, is 8% per annum compounded quarterly lower or higher than 8% per annum compounded yearly? We use the following formula to compare interest rates. 1 plus I is equals to 1 plus I to the power m divided by m all to the power m, where I is the effective interest rate, I to the power m is the nominal interest rate, and finally m is the frequency of the compounds or of the codes. Now let's take a look at an example to quickly explain this term. Interest on a credit card is quoted as 25% per annum compounded monthly. What is the effective annual interest rate correct to 2 decimal places? First things first, we write down our given information. Frequency is 12 because it's compounded monthly, and hence m is equals to 12, and I to the power 12, or I to the power m in this case, will be 0.25, which is the 25% interest rate. And now we are ready to introduce our formula, which is 1 plus I is equals to 1 plus I to the power m all divided by m all to the power m, and substituting in our values, we'll have 1 plus I is equals to 1 plus 0.25 divided by 12 all to the power 12, and making I the subject of the formula by moving the 1 on the left hand side to the right hand side and changing its sign, we'll have I is equals to 1 plus 0.25 over 12 to the power 12 minus 1, and that will give us I is equals to 0.2807. Because this is interest rate, we have to multiply it by 100, as we have divided it by 100 when we started this question, or we divided by 100 at the start of the question. But when we are calculating for it at the end of the question, we multiply the n by 100 to get the interest rate in percentage, and that will give us a value of 28.07%. And that brings us to the end of this lesson. Thank you for joining me, and I will see you in the next one. Cheers.